Imagine trying to have a conversation with someone who has like absolutely zero short-term memory. You sit down, you tell them your name, and literally 5 seconds later, they introduce themselves again.
Yeah, that would be incredibly frustrating.
Right. You tell them your favorite color, and they immediately ask what you like. Because without memory, there's no continuity. There's no context. You are just starting over again and again and again.
Right. It would be impossible to build any kind of meaningful interaction. I mean, every single exchange would exist entirely in a vacuum. You could never refer back to something that was said a minute ago, let alone, build a complex relationship.
And right now, that is exactly how your Python code is operating.
Yeah.
If you followed along with our last deep dive, you learned how to make Python talk. You learned the print command.
Which is great, but...
Yeah, you can make it say hello. You can make it show a number. But the second it showed that value on the screen, poof, total amnesia.
The computer completely forgot what it just did.
Exactly. Let's fix that. Today, we are crossing a major threshold. We are officially graduating to level 2 of Python. And our entire mission today is giving your code a memory. We are going to look at the exact mechanics of how you store information and how you bring it back up when you need it.
It's a huge step.
It is. And I promise you right now, we are skipping the heavy computer science jargon. No lectures on memory allocation or binary chem, just strictly practical, beginner-friendly level 2 concepts.
I love that because this really is the moment you transition from doing, parlor tricks to actually writing software. You literally cannot build a useful application if the computer cannot remember the information you give it. Memory is the absolute bedrock of logic.
Okay, so if Python needs to remember things, it obviously needs a physical or, digital place to put them. To understand how Python stores data, we have to look at something called a variable.
The famous variable.
Right. And the easiest way to visualize a variable is to picture a labeled box. Imagine you have a cardboard box, you put something inside of it, you take a Sharpie and write a name on the outside.
It's a really great starting point, but let's actually scale that visualization up a bit to match what the computer is actually doing.
Okay, lay it on me.
Don't just picture one box. Picture the computer's memory as this massive, sprawling, pitch black Amazon warehouse. It is filled with millions and millions of completely identical empty boxes.
Oh, wow. Okay.
And if you just toss a piece of information into that dark warehouse, it is gone forever. You will never find it again. The variable name, the label you write in Sharpie, is essentially the exact GPS coordinate for that specific box.
So the label is how the robotic forklift knows exactly where to go in the dark to retrieve my data.
I love that. Let's look at an actual piece of code to see how we build one of these boxes. Let's say we want the computer to remember a name. We type this name equals quotation mark, Elizabeth's quotation mark.
Just 3 simple components.
Yeah. We have the word name, we have an equal sign, and we have the word Elizabeth wrapped in quotation marks. If we break that down using our warehouse analogy, name is the Sharpie label we are writing on the outside of the box. Correct. The word name is the unique identifier. It's the GPS coordinate we will use to find the specific container going forward.
Then we have the equal sign. Now, my brain immediately goes to 3rd grade math here.
Sure, like 2 + 2 = 4.
Exactly. In math class, equals means is exactly the same thing as. But in Python, it feels like this equal sign is doing something very different. It's an action, isn't it? Like Python doesn't actually think the English word name is physically the same thing as a human being named Elizabeth.
That is a crucial distinction, and honestly, it trips up a lot of beginners. In programming, when you are creating a variable, that single equal sign is not a statement of mathematical equality. It is an assignment.
An assignment.
Right. You have to think of the equal sign as the physical, mechanical action of the robotic forklift putting the item into the box. You are taking the value on the right side, Elizabeth, and assigning it, or physically placing it, into the box labeled name on the left side.
Okay, got it. The label is name, the physical action of putting it in is the equal sign, and the actual item sitting securely inside the box is Elizabeth.
Exactly.
So now, Python has this box sitting in its warehouse. It remembers that Elizabeth is stored under the label name. But I have to play devil's advocate here for a second.
Okay, go for it.
Why do we even need to build this warehouse? If I want Python to put Elizabeth on the screen, why not just type print Elizabeth every single time I want it to happen? Why go through the extra step of building a box, labeling it, putting the word inside?
Because you have to think about scale. If you only ever want the computer to say Elizabeth exactly one time in its entire existence, then sure, skip the box, just print it directly.
Right.
But real-world software is incredibly repetitive. Think about a banking app or, a social media profile. When you log in, Your name appears at the top of the welcome screen. It appears in the settings menu. It appears next to every single comment you post. It appears on your private messages.
Yeah, your name is basically plastered across dozens of different screens.
Exactly. Now imagine writing the code for that social media app without variables. Every single time the app needs to display your name, the programmer would have had to manually type print Elizabeth. They would be acting like a broken photocopier, just manually repeating the exact same raw data hundreds or thousands of times throughout the code.
And if, let's say she gets married and changes her last name, or just decides she wants to go by Liz,
then you have a complete nightmare on your hands. If you didn't use variables, you would have to comb through thousands of lines of code, find every single individual instance where you manually typed Elizabeth, and painstakingly change it to Liz.
and you definitely miss one.
You would inevitably miss one. Your app would display Liz on the profile, but Elizabeth on the comments, and it would just look incredibly unprofessional.
But with our labeled box in the warehouse,
You store it exactly once. You write name equals Elizabeth at the very top of your program. Then, throughout the rest of your app, you never write her actual name again.
you just reference the box.
Exactly. You tell the code, put whatever's inside the name box at the top of the profile. Put whatever's inside the name box next to the comment.
Oh, that's so smart.
If she later wants to be called Liz, you only have to change it in one single place, right where you originally put the value into the box. You swap Elizabeth out for Liz, and because the rest of the program is just looking at the box, the entire application updates instantly and automatically.
You store it once, and you reuse it endlessly.
Mm.
That is brilliant. Okay, so we know why we use these boxes, but as we start storing different types of information, the rules seem to change.
They do.
For example, let's say I want to store a city and an age. I write city equals quotation mark Paris,
Yeah.
quotation mark, and then write age equals 25. Here is where I get a little tripped up.
Okay.
Why does Paris get wrapped in quotation marks, but the number 25 is just sitting there completely naked?
Mm-hmm.
Why the VIP treatment for text?
It really comes down to how computers process information at their absolute lowest level. Remember, to a computer processor, everything is just electrical signals, ones and zeros. Quotation marks act as a universal signal to Python. Think of them as a protective fence around your characters.
A protective fence.
Yeah. When you put quotes around Paris, you are explicitly telling Python, this is exact, literal text. Do not try to calculate it. Do not try to understand it. Do not look for a hidden command.
Just take these exact literal letters,
Cool.
P-A-R-I-S, and drop them into the box.
Precisely.
Wait, so what happens if I forget the fence?
Yeah.
What if I just type name equals Elizabeth? Like no quotes at all. Doesn't Python just look at the letters E-L-I-Z-A-B-E-T-H, realize it's obviously a human name, and store it as text anyway?
Not at all. Python actually panics and crashes your program.
Really?
Yes, and it panics for a very logical reason. In Python's internal logic, if a word consists of letters but does not have quotes around it, Python assumes that word must be a label for another box in the warehouse.
Oh. Because the word name didn't have quotes around it on the left side of the equal sign because it is the label.
Precisely. So when Python sees name equals Elizabeth without quotes, it interprets that as an instruction to move data between boxes. It says, okay, the human wants me to take whatever is currently inside the box labeled Elizabeth and dump it into the box labeled name.
Oh no. So the robotic forklift races out into the pitch black warehouse, frantically searching for a box with Elizabeth written on the side in Sharpie.
But you never created a box called Elizabeth, you meant it as text. So the forklift searches the entire warehouse, comes up empty, throws its hands in the air, and completely crashes the program with an error.
That makes so much sense. The quotes tell Python, stop looking for a box. This isn't a GPS coordinate. This is the actual physical item. Just hold the item.
Exactly. And the reason numbers like age equals 25 or year equals 2026 don't need that protective, quote, fence is because numbers are a computer's native language.
Yeah.
At its core, a computer is just a breathtakingly fast calculator. When it sees the digit 25, it knows instantly and intrinsically what that is. It knows it's a numeric value that can be used for math.
And it doesn't confuse the number 25 with a box label, because Python rules dictate you generally don't label boxes with just raw numbers anyway.
Exactly. So it takes the 25 and puts it right into the box securely.
Okay, so text requires the quotation mark fence so the forklift doesn't get confused. Numbers can just wander freely into the box because the computer already speaks math. That is a fantastic mental model. So we've successfully stored our data, we have our text securely fenced in, our numbers safely boxed up.
Safe and sound.
But eventually, we are going to want to look inside that box, right? We need to retrieve the memory we just created, which brings us to a massive trap for beginners involving the print command.
Right, because putting things in the warehouse is totally useless if you don't know how to ask the forklift to bring them back.
Right. Let's say I want Python to show me what's inside my name box. My natural instinct, knowing that print puts things on the screen and knowing that quotes are what we use for words, is to type print, parentheses, quote, name, quote, with quotation marks around the word name inside the parentheses.
Very common beginner instinct.
But if I run that code, the screen doesn't say Elizabeth. The screen just shows the literal word name.
Which perfectly illustrates how painfully literal Python is. Think back to the rule we just established about the quotation mark fence. What do quotes tell the computer?
They tell the computer this is exact, literal text. Don't process it. Don't look for a box.
Exactly. So when you type print quote name quote with quotes, Python is being incredibly obedient. It says you put quotes around this, which means you want me to print the exact characters inside the fence. You want the letter N, the letter A, the letter M, and the letter E. Done.
It doesn't even glance at the warehouse.
It completely ignores the fact that you built a box earlier. You told it to print a literal string of letters, so it did.
So taking the quotes off, if I type print parentheses name, just the naked word inside the parentheses that removes the fence.
Yes. Because there are no quotes, Python knows this isn't literal text. It looks at the unquoted word name and recognizes it as a GPS coordinate. It sends the forklift into the warehouse, finds the box labeled name, opens it up, pulls out the value inside, which is Elizabeth, and prints that to the screen.
That is the difference between asking someone to say your name and asking someone to say the phrase your name. It's all about literal instructions versus looking up a stored memory. The quotes dictate everything.
Mastering that distinction, knowing when you're talking about the label of the box versus the literal text itself, is arguably the biggest hurdle in level 2. Once you internalize that, the underlying logic of variables becomes second nature.
Now, what if I change my mind? What if Elizabeth logs off the computer and a guy named Jack logs in? Can I change what is inside the box, or is it permanently sealed?
You absolutely can change it. In fact, that is explicitly why they are called variables, because their contents are designed to vary.
Let's look at how that plays out in code. First, I write name equals Elizabeth. And let's say right under that, on the very next line, I write name equals Jack. What is actually happening in the warehouse? Does the box magically expand to hold both names?
No, the box only holds one value at a time. To understand this, you have to remember that Python reads your code sequentially from top to bottom, one line at a time.
Okay.
So on line 1, the forklift creates the box labeled name and carefully places Elizabeth inside. But then, a millisecond later, it reads line 2, name equals Jack. Python is incredibly obedient, but it only ever honors the absolute newest instruction.
Oh, wow.
It goes back to that exact same box labeled name, physically removes Elizabeth, throws her data into the digital trash, and puts Jack in her place.
It just completely overwrites it. It doesn't give you a warning. It doesn't ask, are you sure you want to delete Elizabeth? It's just gone.
It's just gone. The computer is ruthlessly efficient. It assumes you know exactly what you were doing. The box itself, the variable, stayed in the exact same spot in the warehouse. The Sharpie label didn't change, but the value inside was completely and mercilessly replaced.
That's wild.
So if you were to type print name after that second line, it would output Jack. The computer has no memory that Elizabeth was ever there.
That is slightly terrifying, but also incredibly powerful. Think about a video game. You start playing, and the code says score equals 0. You jump up and collect a gold coin, and the code triggers a new line score equals 100. Then you click another, and it updates to score equals 200.
Exactly.
The box in the warehouse never moves, the label score never changes, the print score command on the screen stays exactly the same, but the value sitting inside the box is constantly being overridden and updated as the game is played.
That is the essence of dynamic programming. You are building static containers that hold fluid, constantly changing information.
Okay, so since this entire system relies on these exact Sharpie labels to find the boxes in the pitch black warehouse, there have to be strict rules for how we write those labels. We can't just write whatever we want.
No, there are very strict rules.
For instance, what happens if I want to use 2 words? What if I try to write the label my space name equals Elizabeth with a space between my and name?
If you try to use a space, the forklift will immediately crash into a wall. The space bar is the absolute enemy of a variable name.
Why does Python hate spaces so much? What is wrong with a space?
To understand why spaces break your code, you have to understand how a computer parses or reads a line of text. A computer doesn't read a sentence smoothly like a human does. It reads left to right, and it uses spaces as literal stop signs. A space tells the computer, this is the end of one specific command and the beginning of a totally new, unrelated instruction.
Like reading an English sentence where the spaces are put randomly, the computer physically cannot group the letters together.
Exactly. When you type my space name, Python reads the word my, hits the space, and stops. It tries to process my as one complete standalone command. Then it crosses the space, sees name, and tries to process that as a completely separate, totally unrelated instruction.
Oh, man.
It has absolutely no idea you intended those two words to be a single unified label on one box. The logic short circuits, and the program crashes.
So how do we fix it? Because sometimes a single word just isn't descriptive enough. If I'm building a big program, name might not be specific enough. I might need username and admin name. We need a beginner-safe solution.
The universally accepted solution in Python is the underscore. Instead of hitting the spacebar, you use an underscore to physically glue the words together. You write my underscore name or favorite underscore color.
It's the perfect bridge. Because visually, the underscore looks enough like a space to our human eyes that we can read it easily. But to the computer's parsing logic, the underscore is a character, just like a letter. So the computer sees my underscore name as one continuous, unbroken string of characters. It processes it as a single label.
It satisfies both the human reader and the machine logic. And that really brings up a larger psychological point about writing good variable names. A label needs to be clear, simple, and meaningful.
I'm so glad you brought that up because it is so tempting to just be lazy. When you are rushing to write code and you just need a box quickly, you might just mash the keyboard. You might type X equals Elizabeth or Q equals 25 or A equals Paris. Technically, Python accepts that, right?
Oh, Python will happily accept it. The forklift doesn't care if the label is AA. It will store it perfectly. Python doesn't care at all. But your future self will care very, very much.
Imagine opening your own code 3 weeks from now. You scroll down and you see the line print up at A. You're going to stare at the screen and think, what on earth is inside of A? Is it a username? Is it a math calculation? Is it a password?
You have completely robbed yourself of all context.
Yeah. You'll have to read through hundreds of lines of code just to figure out what your own box does.
This is a harsh truth every beginner has to learn. When you write code, you are almost never just writing instructions for the machine. You are writing a document that human beings, and mostly yourself, have to read, understand, and fix later.
Such a good point.
If your box holds a favorite food, do not label it X. Take the extra half second and label it favorite underscore food equals pizza. If it holds a test score, label it score equals 100. It removes all the guesswork and makes your code self-documenting.
It's just common courtesy to your future self. So let's lock in these naming rules. We know a variable name can use letters. We know it can use numbers, and this is critical, it cannot start with a number.
Right.
So writing age 2 is perfectly fine. The computer reads it. But writing 2 age is illegal and will cause a crash. We know it can use underscores to bridge words. We know it absolutely cannot contain spaces. And finally, it cannot be a command Python already knows. You can't name your box print because Python already uses that word for something else.
If you follow those structural rules and you prioritize making the names descriptive, your code will be vastly easier to maintain.
Let's take a step back and look at the massive leap we've just made. We started this journey with a computer that suffered from total amnesia. It could speak, but it instantly forgot everything it said. By introducing variables, we've built a sprawling warehouse for Python to store memories.
And we know that a variable is just a labeled box defined by an equals sign that physically places a value inside.
Right. We learned that if you are storing text, you must build that quotation mark fence around it, so Python knows it's literal text and doesn't go searching the warehouse for a box that doesn't exist. But numbers are the computer's native language, so they go straight in completely naked.
Exactly.
We conquered the print trap. Understanding the massive difference between print quote name quote, which literally just types the letters N-A-M-E, versus print name without quotes, which sends the forklift into the warehouse to retrieve the actual stored memory.
A huge distinction.
We realized that these boxes are ruthlessly overridden the second a new value is assigned. And finally, we learned how to name our boxes responsibly. Underscores are your best friend, spaces are your absolute worst enemy, and descriptive names save you from tearing your hair out 3 weeks from now.
It really is the foundation of everything that comes next.
It totally is. And to truly cement this new architecture in your brain, I want to leave you with a challenge exercise. Your mission is to write a tiny 3-line program that utilizes everything we just discussed. I want you to create a variable to store your name. Then create a second variable to store your age. Then a third variable to store your city.
And remember the rules. Quotes for text, no quotes for numbers.
Yes. Use underscores if you need them.
Well.
Once you have those 3 boxes created and filled, write the print commands to output all 3 of them to the screen one by one. Write it out, test it, and if you get it working, share your code in the comments. Prove you've conquered level 2.
It is the absolute best way to ensure these concepts have transitioned from abstract ideas into practical skills. And as you are writing that code, as you are carefully creating those 3 little labeled boxes for your name, your age, and your city, I want you to consider the scale of what you've just learned.
Oh, what do you mean?
Well, if a single variable box in that pitch black warehouse can hold a short word like Elizabeth or a simple number like 25, how big can these boxes really get?
Wait, can they hold a lot more?
What happens when you need to store an entire encyclopedia, every single word and chapter inside one single label? Or what happens when you need to store a list of 1 million different users, all with their own names, ages, and cities, inside one single container?
Oh, wow, that's wild to think about.
That is where the real power of Python begins to unlock.